So my expression that came for linearization approach was that I have hn plus 1 that will be equal to hn plus delta t minus c root of h tilde upon 2 plus f of t n plus 1 divided by 1 plus c delta t upon 2 root h tilde. So the problem will boil down to that first I will calculate h tilde, that will be equal to hn. Then I will find out hn plus 1 using equation 1. Then check for convergence. If it is no, then what I will do, my h tilde will become hn n plus 1, and from here I will directly jump to this point. And if it is yes, then move to next time step. So here within one time step we are basically trying to do the loop formation. Now I will give you algorithm for both these approaches. The first approach was Newton-Raphson approach and the second approach was the linearization approach. So let us write down the Newton-Raphson approach. So we had, what we had is f of hn plus 1 is equal to hn plus 1 minus hn minus delta t minus c root of hn plus 1 plus f of t n plus 1 is equal to 0, and we needed to find out the solution of this function of hn plus 1 is equal to 0 within each time step. So my solution was that within each time step I will loop it. Hn plus 1 new will be hn plus 1 old minus f of hn plus 1 old divided by f prime hn plus 1 old. So this was my expression. So the algorithm will become that, my algorithm is that first, so the algorithm is that first we have hn comma f of tn comma delta t and c and f of t n plus 1. This is what we have. So we will assume that hn plus 1 old is nothing but hn. We will calculate f of hn plus 1, f of hn plus 1 old. Then using these values we will calculate the hn plus 1 new is equal to hn plus 1 old minus f of hn plus 1 old divided by f prime hn plus 1 old. Now we will check hn plus 1 minus hn plus 1 old new. If it is less than a error, if it is no, then I have hn plus 1 old is equal to hn plus 1 new, and I will directly jump from here to here. And if this thing is yes, then my solution is converged. I have hn plus 1 new, that is the value of hn plus 1 at new time step, and I will move to next steps. So this will become my algorithm. So the first step is that I have from previous values. This is my first step, this is my second step, this is my third step, this is my fourth step, and this is my fifth step, and depending upon this I can go either this way or that way. So this is algorithm. So I will make this line very clear for you to understand this. This is algo for Newton Raphson approach. The second approach was that I have the linearization approach. For that, the expression was hn plus 1 is equal to hn plus delta t minus c root of h tilde divided by 2 plus f of t n plus 1 divided by 1 plus c delta t divided by 2 root of h tilde. So the algorithm will become that first I have hn comma f of tn comma delta t comma c comma f of tn plus 1, and these values are known. So I will assume that my h tilde is nothing but hn. I will calculate hn plus 1 is equal to this expression, expression 1, and then I will check for convergence. Hn plus 1 minus h tilde is not, if it is yes, if it is no, then my h tilde will become hn plus 1, and I will go to this step, and if it is no, if it is yes, then I have the hn plus 1, that is nothing but h tilde, and move to next step. So this is how my algorithm will look like. I am giving you another example of this thing. So suppose I have an example for this. So suppose my ODE is dt over dt minus c t to the power 4 is equal to f of t. T at t is equal to 0 will become ti. So this kind of ODEs appear when we solve the radiation problem. In that case, we have t to the power 4 that comes into the picture. So first is explicit formulation. So explicit formulation says Tn plus 1 minus Tn divided by delta t is nothing but Ct2 Tn to the power 4 plus Ftn. So that will give me Tn plus 1 is equal to Tn plus delta t C t to the power n4 plus Ft to the power n. So this is my explicit formulation, and we do not have much trouble in doing explicit calculation. The second part is the implicit part. Implicit part, we have the ODE dt over dt is equal to c to t to the power 4 plus ft. So that will make t to the power n plus 1 minus t to the power n divided by delta t is equal to c t to the power n plus 1 की power 4 f of t n plus 1. So we have this t to the power n plus 1 minus c delta t to the power n plus 1 की t to the power n plus 1 to the power 4 minus t to the power n minus delta t f t to the power n plus 1 is equal to 0. So this is my function of t to the power n plus 1, that is nothing but t to the power n plus 1 minus c delta t tn plus 1 to the power 4 minus tn minus delta t f of tn plus 1, and I need to find out the solution of f tn plus 1 is equal to 0. So this becomes a Newton-Raphson kind of approach. I will find out that t to the power n plus 1 nu is nothing but t to the power n plus 1 old minus f t to the power n plus 1 old divided by f prime t to the power n plus 1 old. So this is my formulation. The next part is the linearization part. So I have t to the power n plus 1 t to so my expression was that t to the power n plus 1 minus minus c delta t, t to the power n plus 1 to the power 4 plus t n minus delta t f t n plus 1 is equal to 0. So I am trying to do the linearization thing. So t to the power n plus 1 to the power 4 will become t tilde to the power 4 plus 3 t, sorry, 4t tilde to the power 3 t n plus 1 minus t tilde. So that is t tilde to the power 4 minus 4 t tilde to the power 4 minus 4 t tilde to the power 3 t n plus 1. So this gives me the expression that my t n plus 1 will be delta t t n plus 1 will be so suppose if I put that expression into the into t n plus 1 will be c delta t minus 3 t tilde to the power 4 minus 4 t tilde to the power 3 t n plus 1 plus t n minus delta t f of t n plus 1. That gives me an expression that my t n plus 1 will be delta t minus 3 c t tilde to the power 4 plus, so this is my plus, this will be plus f of t n plus 1 plus t to the power n divided by 1 minus 4c delta t tilde to the power 3. So this is my repetitive expression. This is like a regular falsy approach. So we will assume t tilde, we'll calculate this, and then tn plus 1 we will calculate using this expression. We will find out the error between tn plus 1 and t tilde, and if the error is less than a particular value, then the solution is converged and we will move to the next step. If it is not converged, then tn plus 1 will be assumed as t tilde, and we will repeat this calculation till we achieve the convergence. So this was all about a single nonlinear ODE solution method. In the next video, we will talk about system of nonlinear ODEs. Thank you.